I'm Lucas Hogan. I'm a senior lecturer in the Civil and Environmental Engineering Department at the University of Auckland, and the project that we have here is looking at the resilience of existing bridges on the New Zealand State Highway Network. So with the testing that we're doing here, what we did is extract out existing bridge columns from a bridge that was being demolished. The bridge was about 85 years old, and it happened to be a really good representation of many other bridges on the State Highway Network. So we bring it into the lab and we put it on our strong floor and we push and pull on it to simulate an earthquake. And if we understand how this bridge behaves, it really gives us great insight into how similar bridges around the State Highway Network would behave, and really how resilient are they to an earthquake, and how likely are they to be able to function and get emergency services across, allow people and communities to recover quickly after an event.
My name is Anna Seabal. I am a PhD student here at the University of Auckland. The bridge is, the axial load that's going down on it is going to be 30 tons on either column, so 60 tons in total. And then we're pushing on it with a force up to, this one got to 28 tons. I think the highest we've seen is 30 tons getting pushed onto one of them. And so I am actually putting in just the distance that I want to push it out to. So I'm not messing with the force. I just say this is how far we want to push it out. And then I put that in, the actuator pushes it, and it gets a reading of the force and then that displacement. After that, we go up of the scissor lift, and we actually start measuring what happened. That's a lot of that qualitative analysis. So looking at how big these cracks are, what is different in this bridge versus the last one, measure all that, we map it out, so we actually have it drawn for each one of these. Then we go down and we do it again.
So the retrofit solution that we're looking on is, the idea is to try to contain the concrete. So as the bridge piers are moving back and forth, the concrete's pushing down and it wants to spall out. And so the idea is to provide some containment to that, just like you would the steel belts on a wine barrel. And this is called jacketing. And jacketing of bridge columns has been used for many decades overseas, and in New Zealand it works really, really well. The challenge with traditional jacketing is that it's expensive. And so if you have sort of an overpass style bridge where you have 1 to 4 columns that you have to jacket, and that's the only thing which is providing resistance to the earthquake, yeah, it's worth spending all of that money to get the resilience.